Good morning all. I'm Padmasini, Assistant Professor, Department of Information Technology, M.O.P. Vaishnav College. Today, we are going to see about the types of attribute selection measures in classification technique under data mining. So data mining is a process used by the organization to extract specific data from huge database. It primarily turns a raw data into useful information. To have a broad idea about data mining, it is classified into two major tasks. One is predictive, another one is descriptive. Predictive task is classified again into classification, prediction, regression, and time series analysis. And then descriptive, it is clustering, summarization, association rules, and analysis. Now we are going to concentrate on the classification techniques. So moving on to the advantages of data mining. Data mining enables the organization to obtain knowledge-based data. It enables the organization to make out lucrative modifications in the operations. So when comparing with the statistical data analysis, data mining is a cost-efficient one. Data mining helps for the decision-making process of an organization. So, and it facilitates the automated discovery of the hidden patterns and to predict future data. Moving on to a classification. Classification is a process of analyzing structured or unstructured data and organized into various categories based on file types, metadata, etc. So the goal of the classification is to predict the target class for each case in the data set. There are different types of classification techniques. So today we are going to see about decision trees. A decision tree is the most robust classification technique in data mining. A decision tree is a structure which includes root, then internal nodes, and then leaf nodes. So each tree has a root node and branches to the next internal node. Every internal node refers to a condition, and then each branch stands for the outcome of the test. So outcome will be the class label. So this is a sample diagram for a decision tree. So the algorithms that comes under decision tree are ID3, C4.5 and CART. So there are various attribute selection measures. They are information gain, gain ratio and Gini index. So we are going to see this in detail. So let us take a data set of the COVID data set, whether the patient is tested positive or negative. So the infected column which is available says how many cases are tested positive and how many cases are tested negative. So yes denotes positive and no denotes negative. So there are three features which is available in the data set are fever, cough and then breathing issues. All these attributes plays a very important role to find out whether the patient is affected with COVID or not. Totally, there are 14 records, out of which 8 are affected positive with COVID and 6 are negative. So now let us compare the attributes with the infected information. So according to the first attribute, it is fever. So we'll consider fever with the yes case and fever with no case. Now we are going to compare fever with the class label, that the class label is the infected target label. So we have fever yes case is 6 and then fever is yes and the infected information is no is 2. Again, fever is no and the class label is yes is again 2 and then fever is no and the class label no is 4. So like this, we have to calculate the information for cough and breathing issues. So this is the primary work for calculating the attribute selection measures. So we have to remember all these numbers to find out the information gain and gain ratio. So fever, we have 6, 2 and then 2 and 4. Cough, 5 and 3 and then 5 and 1. Then breathing issues 7 and 1 and 1 and 5. So now we'll move on to calculate the information gain. This is the first attribute selection measure. Okay, so first is we are going to find out how many infected patients for COVID overall. So this is a formula for calculating the entropy here. So there are 14 records totally, out of which 8 are tested positive. So that is 8 by 14 into log 2 of 8 by 14. And out of 14 records, 6 are negative. So 6 by 14 into log 2 of 6 by 14. So I get 0.984. Now we are going to find out what is the relation between fever and then the infected persons. Now we'll consider the fever case with the class label yes and then class label no. So we are going to have the same formula implementation. The totally 8 records, out of which 6 is yes and then 2 is no. The same way you are going to calculate for no here. Out of 6, 2 is yes and then 4 is no. So we are getting the values 0.81 and 0.91. Now we are going to find out what is the information gain related with fever. So this is the total number 0.984, this number, minus there are 14 records, out of which 8 are positive. So 8 by 14 into whatever value we have got for the fever, it is 0.81. Minus, again out of 14 records, 6 are negative, and what we get for the fever as negative, it is 0.91. So for making this calculation, we could get 0.13 as the information gain for fever. Now let us see for cough. What is a class label for yes related with cough category? So out of 8 records, 5 are tested yes, and then out of 8 records, 3 is tested no here. Again talking about the class label no, out of 6, 5 will be yes, and then out of 6, 1 will be no. So like this we are going to calculate the yes category is 0.94 and no category is 0.65. Now, what is the information gain of cough? It is 0.16. Now, we are going to calculate for the breathing issues here. So, here we are going to calculate the class label for yes and then class label for no. It is entropy for yes. The same way you have to do for the other case also, 0.54, and for no, it is 0.65. So, we got the information gain for all the 3 attribute selection. So this is the consolidated view for the information gain based on different features here. Fever we got 0.13, cough 0.16, and then breathing issues 0.39. So according to the information gain, whichever number has the highest one, that will be the root of the decision tree. According to this data, 0.39 will be the root of the decision tree, followed by cough 0.16, and then fever followed by 0.13. Hope all of you understood the first attribute selection measure. Next, I'm moving on to gain ratio. The formula for gain ratio is information gain divided by split information. Now we know what is the value given for the information gain of various attributes. Now we are going to collect, or now we are going to do the splitting information for all the attributes. First one is fever, second one is cough, and the third one is the breathing issues. So the splitting information formula is out of 14 records, 8 is positive, and here 14 records, 6 is negative. So we are going to find out this. So we have 0.984. The same way you're going to calculate for cough and then breathing issues. Now we'll calculate the gain ratio for fever. It is 0.13 that we already found in information gain. Information gain divided by 0.984. So that is the value we got it here. So the gain ratio for fever is 0.132. Next one is cough. The gain ratio is, already we know the information gain is 0.16 divided by this value 0.863. So we have 0.185. Next one is breathing issues. So gain ratio is 0.39, which we already found. Now we got the value as 0.984 as a splitting information. So we got here 0.396. So the total consolidation of the attribute measures according to gain ratio is fever is 0.132, cough is 0.185, and breathing issues is 0.396. Again, for gain ratio, the highest value is considered as the root of the decision tree. So according to the value, we can easily find out the breathing issue will be the root, followed by cough, then the fever. So next we'll move on to the third type of attribute selection measure, that is called as Gini Index. So this is a formula. Now we'll see how to calculate the Gini Index. So here, the fever case, yes. So this is a formula, that is 1 minus totally how many yes you have. So out of 8, 6 is yes here. Again out of 8, 2 is no here. So like this you could find out 0.375 is the value. Again, when the fever is no, we are going to calculate again 1 minus out of there are 6 no's. So here 2 and then followed by 4. So what happens? So Gini index is 8 by 14. 8 are positive cases. 14 is the total records into this value 0.375. Plus out of 14, 6 is negative. So 6 by 14 into 0.44. So we get 0.402. So this is the relation or the Gini index of fever related with the infected case. Next one, we are going to calculate for cough. So cough is yes. So the Gini index value is 1 minus. There are totally 10 yes cases here according to cough. So it is 5 by 10 is yes and then 5 by 10 is no. So we are getting 0.5. Next, again for cough, no, it is 1 minus 3 by 4 into 3 by 4. So there are four records, out of which 3 is yes and 1 is no. So we are getting 0.375. So to find out the Gini index of cough will be, so out of 14 records, 10 records is positive. So that is why 10 by 14 into 0.5 plus out of 14, 4 is no. So 4 by 14 into this value, whatever we found out, 0.375. So totally we have 0.4642. So like this, we are going to calculate for breathing issues also. So the consolidation figure of the Gini index of the different attribute measure here is fever is 0.402, cough is 0.4642, breathing issues is 0.218. According to Gini index, the lowest value will be considered as the root of the decision tree. So again, the breathing issue has the lowest value. So 0.2138 will be the root of the decision tree, followed by fever. Fever has 0.40, so that will be the next of the decision tree. And then cough, it is 0.4642. So these three types of attribute selection measures, information gain, gain ratio and Gini index, is used in various classification algorithms such as ID3, C4.5 and CART algorithms. Thank you.